Hey everybody. So this is not a code lecture. It's like a spreadsheet discussion lecture, which might seem like a bit of a diversion. But fundamentally, why we talk about this, two reasons. One, spreadsheets are still sort of like the most common way most of us deal with things in R and Python and other data formats. Even when you're reading more complicated databases, relational databases, things like that, often you end up, creating some sort of spreadsheet to do your actual analysis on. Even if you're, pulling in JSON files from some API, you often end up creating some sort of spreadsheet. Or the reason that is partly because when you go to do like the regression modeling or something, it's still are, those packages typically expect you to, feed in some sort of flat file, like a matrix type format or some sort of data frame. Data frames in R, matrices in R are sort of essentially just spreadsheets that live within R. And so that's the first reason. The second reason is the principles of sort of good spreadsheet practices are not limited to spreadsheets. And so they're sort of a good test case for thinking about these things, but ultimately a lot of it is not about spreadsheets as well. So three quick objectives for this discussion. Understand what we mean when we talk about like tidy data. Tidy is like a special buzzword in R because there's a set of packages within sort of a package family called the tidyverse, and so people in R love throwing that tidy phrase around. But there are certain principles embodied within that aren't just jargony that we'll talk about. Second thing is knowing sort of common formatting and data entry mistakes to avoid, and then the third thing is introducing the idea of dates as data. So a couple points about formatting. So first, if you have raw data, like you've taken, you've gone out and taken like soil samples or something, you never, ever, ever want to edit directly on those raw data. So you start with that raw data file, make a copy of some set of saved values, like, save as, make a new copy, edit on that. Or if you're editing in R or something, like create a script that takes and edits, you don't want to save over the top of those original data. You want to save a new object, so you always have sort of those root data that you are going with. It's actually a good reason as well to use R if it's feasible. Like sometimes it's unavoidable to like open up Excel and like point around and edit things. But if you can use scripted language to do it, it makes it a lot easier to document your steps, because best research practices, you start from those original data and you discuss the cleaning and modification and adjustment steps you made. If you're doing that in script, that sort of happens automatically because you're just doing it. If you're pointing and clicking and typing around, then you don't automatically have a record of that, right? You're not like tracking what you're doing in Excel, and so you need to keep some sort of documentation. Okay, so you have a spreadsheet. It's not your original data. You've saved as, created some sort of new file. A couple things about organizing. So each column is going to be some variable, not each row. So that's an important distinction, right? It's sort of every once in a while you'll find someone has like stored data the opposite way, where like each row is a variable and it goes out. I guess Excel will tolerate that. If you try and use that stuff in R, you're going to have a bad time. So we're always thinking variables in columns, observations in rows. Second practice within that, each like row column combination only has one value. So we don't want cells where you've like stored a couple different things, like one value, comma, second value, that sort of thing. Every cell in your spreadsheet or like in your R data frame should have one value within it. You can see an example if you pull up this lecture in the course materials of a bad example where someone, for instance, has combined species and sex with a dash in between or a hyphen in between. And that's, I guess you could back that out. Liza and I do a lot of regular expression work, which don't worry about what that is, but it would allow you to like split those off again. But it's just simply not a good way to store your data. A couple other mistakes, and again, this might be stuff you do already, but it's just sort of good to have a conversation about and keep in mind. One, we don't want that multiple tab thing that Excel lets you do, right? So we've all opened those Excel workbooks. There's like 12 tabs, and so there's essentially like 12 spreadsheets stacked on top of each other. R can handle those. Like you can read in a particular sheet from a workbook, but it's just really it's not good practice. You want to have a separate file for each sheet rather than a stack of sheets in a workbook. Um, Next idea is sort of relates to that. Again, a lot of the stuff happens because Excel is sort of robust to like crazy workbook behavior in a way that other things aren't. And so what might be common in Excel simply isn't. We don't want to spread data across multiple tables either. So we talked about the tab idea, but you also don't want, I'm sure you can picture, you've seen a spreadsheet where there's like a table in one corner and then it clicked over a couple columns and there's like a table in another corner, something like that. It's really hard for programs that aren't Excel to deal with that sort of thing. So you don't want to store like multiple things in different parts of a spreadsheet. You want single spreadsheet, no separate tabs, and then whatever you have is in like the top left corner of that spreadsheet. There's not like other info hiding somewhere else on that spreadsheet or like a totally separate table. So one tab for data sheet, or one tab for spreadsheet, and one table for spreadsheet as well. Uh, when you can, another important point is don't record zeros as blanks. That sounds silly, but zeros are real values, whereas blanks are NAs. And so if you leave a blank for a zero, R is going to code that in as an NA when it tries to read in. And then you also want to make sure you're picking an appropriate null value. So there's a screenshot from a paper that we link to on the course page in the course materials section that goes into this in more detail, but you'll see all different kinds of formats, right? People put in random numbers, they leave it blank, they use NAs, they write none, they write no data. A lot of those are not great options for reasons we won't get into. The best practice for us is probably that capital N, capital A. R likes that unless like for some reason you're using NA for North America or something like that. NA is probably a good value. Null, all capital letters, is also a good value as well. That's a special object in R, which we haven't talked about at all. Perhaps we will at some point, but those are probably our best bets. A couple other things, no one cares about pretty spreadsheets. Enough said about that. No colors, no fonts, and nothing about that. Make sure to likewise, like you're not anything you're reading in where you have like like the Visual Basic code you can do under the hood in Excel, where you're doing like conditional formatting kind of stuff, where you're like, if this, print out this, do this thing. All that gets lost, right? So you want your spreadsheets to be like simple. What you see is what there is. Don't store your comments in like with the data. So Excel will let you make comments just like it's a Word doc. If you do that, they're just gone. You actually have to record the comment as like an item in a different column. Make sure to keep the units in your column name rather than in the actual value. So you don't want like so you have a column of dollars. You don't want $ number, $ number, $number. You want the $ in the column header. The reason being is that when you read in $ whatever, R does some guessing essentially, and it says like, oh, these aren't all numbers. This must be a character or something like that. And you actually had a numeric column. You could always convert it on the back end, do what you need to do, but it's not sort of best practice. Liza mentioned in class that there's sort of as a general convention, we want to avoid spaces in like data names and file names and column names. That holds true. Also, good idea, if you can, try and avoid numbers and try and avoid special characters as well. So you don't want to see like the @ sign or the pound sign or things like that as like column headers or anything like that. Okay, so that's sort of a lot of just like old person yelling at clouds about like best spreadsheet practices. You don't have to memorize all those. Mainly what you want to be thinking about is we're moving into this land of clear, transparent, and reproducible research. And things that are happening on an Excel file on your computer are often the exact opposite of that. And so every step of the way, you want to be thinking about how can I point to like a simple, easy, error-free start to my research that then I can apply all this code, or someone else can apply all this code, and take that clear, unambiguous start and go all the way through to these results I'm presenting. And so every step of the way, you want to be thinking about how you can make sure that you're sort of starting in that simple, error-free place. Along with that, right, there's all sorts of horror stories in science about Excel and other programs like that, like mishandling things like dates, which we're going to talk about dates in a second here, and people getting like totally erroneous research results because like Excel didn't handle the values well or something like that, or like the values were read in wrong when you read it into R, your research program, or something like that. And so again, you want that like simple, unambiguous start so you're off on the right foot. Okay, let's go to dates. Uh, Excel just does weird things with dates. We'll leave it with that. But the important thing to remember is that Excel, one will like often try and convert everything to date. So if you have something that isn't a date, Excel might just like convert it on you, and it won't tell you when it does that, and it doesn't always interpret it as you want it. And so it sort of like tries to take dates and turns it into like a more complete date. So if you had like July dash 10 is one example we use, July hyphen 10, R might or Excel might interpret that as the 1st of July 2010, right? So it just does all this complicated stuff. Um, so the best rule of thumb here, rather than trying to memorize that and handle it all, is two things. One, if you can, treat dates as multiple pieces of information. So instead of a date in a column, have the month in a column, separate column for year, separate column for day, separate column for time if you need it. You can always piece them back together again, but that makes sure nothing wonky happens. And then second, just try not to let Excel handle dates, right? That kind of goes with that first piece of advice, because if you just have the month as a column, Excel doesn't really know that's a date. You just have the numbers like 1, 2, 3, 4, whatever. It's just going to keep those. And so you're sort of not letting it do anything. All right, I'm going to let you peruse the rest of this on your own in terms of thinking about exporting and quality control. I think these are things you're likely familiar with, right? In terms of like you're exporting a CSV file or something like that. So I think we're all kind of on the same page. Again, we're just always thinking about how to do error-free, replicable, transparent research. All right, thank you for listening, and let me know if you have any questions.